Good evening. Welcome to our campus. It's a pleasure today that we're going to hear Dr. Mohsen Kashi talk us on his work about the restoration of the earthquake damage Arg-e-Bam following the earthquake that happened in 2003. So I'm not going to talk about his work. He's going to give you, I guess, a thorough introduction about it. But I'm going to briefly go over his background. Dr. Kashi received his PhD and master's degrees, and feel free to correct me at any point, in civil engineering from Virginia Polytechnic Institute. And he's a professional engineer right now, working in a lead design engineer company, if I'm not mistaken, AECOM. AECOM is the name of it, and which is one of the largest engineering firms actually in the world, the Boston office, if I'm not mistaken. He has more than 28 years of professional experience, both in Iran and US, and he has been involved in many projects. One of them, the Central Artery project in Boston. One of them I got to know about, if I'm not mistaken, is the Tawhid Tunnel in Tehran. And I know you have done some work in north of Iran too, in one of the big dams. Is it Siyar Dam, and many other exciting works, and as well as the as you're going to hear today, the rehabilitation of several historical structures in Iran. So I got to know about this exciting work as I was chatting to Dr. Kashi about something entirely different, and I'm glad you got a chance today to present his work to a greater people in the Boston area. So with that kind of brief introduction, please join me in welcoming him to our campus, and we're looking forward to his talk.
And basically I got into this project very much by accident. I was in Tehran one day, and the student showed up in my office in Tehran and said, "We want to set up a lab." This was like about 3-4 months after the incident. We want to set up a soil lab there, site, to do some work. I said, okay, let's go see what's going on. So that's how I got involved with the whole thing. I have thousands and thousands of pictures of this, which I had to comb through and narrow down to what I have to present to you tonight. And so feel free to interrupt me and ask questions anytime you think you need to. Right. How do I get a little bit dimmer light here? I don't know. So everybody is okay with the picture rotation? Okay. Well, okay. I go through an outline first. Where the location is history. That history I'm talking about is very brief history that I can go over. And then 2003 earthquake incident, restoration of historical sites as guidelined by UNESCO and some other international organizations. The research we conducted there, and restoration of the pilot structure. In other words, we were not given there was no budget per se. Our work was mostly charity work, but they didn't have enough budget to restore the entire system. They said the estimate was by UNESCO about $2 billion at the time. That I'm talking about back in 2003. So a lot of these projects, what we did was we had a lot of students that we used as a slave, sending them to the site, and they stayed there. The client, the owner, basically, they paid for their accommodation over there, but other than that, they didn't get paid for it. All right. I'm sure everybody knows where BAM is. It's close to Pakistan, here in southeast Iran, in Kerman province, and BAM is here. And it's all desert. And somebody may ask why we have a town in the middle of the desert. And I give you the answer is because of earthquake. It's very interesting. The reason is, like everywhere else, civilization flourishes where the source of water is. So, due to earthquake, geological condition of the ground had changed in the sense that impervious layers have come up. So if it's a layered system in a geological system, you have a pervious like a sand, and then clay, and going down to bedrock. If you have clay, clay normally is impervious. The water path does not pass through it. So they had a fault there. Due to this fault, dislocation of these layers, a layer of clay has created a dam in front of a pervious layer. So the water that comes from the northern part of the mountains entraps behind this layer. So it was a source of water. And they have canal system, and I'm sure the Iranians know what I'm talking about, several thousand years old irrigation or water transmission systems that are existing in Iran. And a lot of them are already registered in, by UNESCO as, World Heritage. And there one very exhaustive one here, a huge system, which is partially damaged due to the earthquake. But people diverted the water to this place. This is actually one of the areas that is, dates are cultivated. It's very high arid region. And I don't know if I have a picture of a lot of beautiful gardens there. I mean, the dates actually the pond. Okay, this is a picture of several years ago when it was intact. And this is a closer-up picture from going back. The area up there is, they call it Hakim Nishin, or what should I say, the governor were living up there, that place. And this is a wind column, or Badgir, I don't know how else I can translate into English. The bottom line is that they collect water, and there are collect air. Wind passes through this, and through the chimney effect, and they have a source of water down here. It cools down natural cooling of the enclosed spaces. Again, this is a little bit close-up picture of that governor corner. Location and history, it's the largest adobe building in the world. Along the ancient Silk Road, which is very famous, now is along the narcotic road. It's the main passage of narcotic from Afghanistan to Europe, passes through Baku. 180,000 square meter is the total area of the whole citadel, or the Arg. And it dates back what am I doing?
I think it's going forward, maybe. Okay.
All right, I was here, right? Okay. All right. It goes back to Hakamanishyan era, which the archaeologists said is a long older than that. They say it's about 500 BC or so. They say it's basically the history goes back to 5,000 years. It's very, very old. It's been damaged due to numerous earthquakes, rebuilt. Because the archaeologists, after this particular earthquake, they showed us, for example, change of function. There was a place that it was amazing that I didn't know, it was a mosque totally demolished due to earthquake. And then you go over there, it was like stairs. They said this is the place they used to make wine. It was funny because it was like a bowl going at different levels of ground. And he showed actually how it worked, because they found the potteries that they put the final product in there. That they put grape in where they walk over it or something to smash it, and then the water passes through one and goes to the second one, and the settlements, and then go to the last thing, and they bury the thing over there. So this stuff started unearthing. Several things when I was there unearthing. In Farsi, you guys have heard that they said, I should say it in Farsi, I don't know how to say this in English. They say, I didn't know where that comes from. They said, in English, they said, okay, this guy is worth put it in the middle of the wall. Right? But we found out some of the walls that were broken, human beings standing right in the middle. They were type of punishment. I don't know how many years ago, that they were buried in there. We found a lot of this kind of stuff, artifacts, which are all unearthed after the earthquake. So it was a huge archaeological work over there. So working of restoration was the last thing in their minds. They were excavating a lot of things over there. Anyhow, it's registered as a World Heritage Site. Okay. During Queen Farah, this site was basically restored for becoming a tourist attraction. Prior to that, some people actually lived in there. But during early 60s or early 70s or late 60s, they bought this property and they restored it to something that is attractive to tourists. So a lot of these additions you see up there, these are what was done. It was not there. Then you go back to very, very historical pictures. It's one of the sites, by the way, that is well documented. Has a lot of pictures. A lot of people from at least 150 years ago, they have track record of doing the surveying and put a map to it and stuff like that. So it's very well documented site. And again, they had a tea house there. These are all before earthquake, just to have for the tourists to. This is a clay model of the whole site. Somebody actually, there are several of these actually were scattered all over the city of Bam. These are all prior to earthquake. Somebody sat down and made this stuff. I don't know if it was a high school project or actually, but anyhow, this is a picture of one of those. This is one of the earliest pictures that I found during, I don't know, 78 years ago. As you can see, the shepherds here, some people up there. This is another one. Nader Shah used this. I mean, in the history you read that Nader Shah used this for a while. As a garrison. Anyway, this was a very important town back in the history on the way of the Silk Road. And it's a very nice example how people in desert live. As far as their lifestyle is concerned, the housing they made, and how they lived in general. A lot of this was deduced from this. 2003 earthquake, 6.5 Richter earthquake happened early in the morning, 26th of December of 2003. More than 43,000 people were killed. And more than 40,000 people injured, and the whole town, I will show you some of the very devastated pictures that we have there. Damaged a lot of historical sites, including Bam, Arg. And they had this, as I said, they have this canal system, agricultural thing for the water, that a lot of those were damaged. And, okay, these are some of the pictures of the earthquake damaged town itself. And it's funny, you can look at it, all is modern material, steel and masonry structure. Look at that steel, and nevertheless, it's just not built for earthquake. Okay, I'm going to show you this following work is a genius person with the name Randolph Mangerbach. He is part of this organization. He traveled to Bam. He got all the pictures from the tourist organization, and he built this, which is quite genius. Okay, the whole earthquake took 12 seconds. And that's what happened. So this is the before effect, and this is the after effect. This is very close to the Hakim machine or the governor corner. that's after. This is before, this is after. This wood path was placed there for people not to walk on the rooms, actually walk on the platform to keep it as it is. I'm talking about this. These are all placed after earthquake. Okay, this is another before. It's a very old picture. This is after. This is before.
Was these before pictures were restored actually?
The before pictures, oh yeah, these are right before. These are the pictures actually the Department of Tourism organization used for propaganda, I mean for getting people there. So it is definitely after restoration of whatever was done prior to the earthquake. And this gentleman, he took all those pictures and when found the angles where those pictures were taken and took the room picture and overlapped. It's quite an art, I don't know how he did it. So this is before, this is after. This is some of the pictures from inside. This is the part that I had nothing to do. So now we go to the part that we did. Okay. Now we talk a little bit about the restoration. UNESCO guideline has a strict guideline. According to UNESCO, you are not allowed to rebuild if you want to have it basically registered as a World Heritage. You're not allowed to rebuild. For example, somebody says Takht Jamshid. Why they don't rebuild? Why they just keep it the way it is? They're not allowed. The reason is that they are not allowed is these are very old historical structure that has very little documentation what it was before. So most of what it was before is guesswork that people, archaeologists, guess, and based on that, so they do not allow you UNESCO. You can. It becomes like a Disney World, and it no longer has historical value. So in order to keep the authenticity, you are not allowed to build it beyond what you know about it. So definitely if you have good track record of what the building or structure was before damage, you can put it back to the same system using exactly the same material. However, if you want to add to it, in case that we did, I'm going to go over it later on, it needs to be something that is reversible. In the sense that if 100 years from now somebody wants to say, okay, I want to see the original structure, they can rip those stuff away and end up with the original structure. That's the extent that they allow you to rebuild or restore a historical structure. And according to Economos, reconstruction means returning a place to a known earlier state and is distinguished from restoring the introduction of a new material into the system. In other words, if you are introducing something, it needs to be actually, the person who goes and sees as a tourist or whatever, needs to see with the naked eye that what was added to this. I don't know how many of you guys have gone to Rome for Colosseum, for example. It's all stone structure, and it's been rebuilt, restored. Italy is also very earthquake. But you see, it's all outside. These are metal straps outside the building to keep it together. Internally, otherwise, what you can do, especially in this case, you can build a concrete structure, earthquake-proof, and then plaster it with kagel or plaster it with clay, then it looks like the original one, but you're not allowed to do that, basically. And the direction given by UNESCO to everybody who are working, there were several teams A few months after the earthquake, came to Iran and started working with our team. Team from France was there, team from Germany was there, and team from Italy they were there. And each one they were doing different things. For example, the Italian team, what they did, they didn't participate in restoration at all. What they did 3D laser surveying of the entire facility. So it's all established what would happen after earthquake. So they have, you know, a track record of what's going on as far as the earthquake is concerned. Okay, what we did was trying to apply modern idea to restoration of historical structures. And then construction material property, design of a grout. I will go over each one of these. Choosing reinforcing material, evaluating the type of structural damages, restoration of one typical structure as a pilot. In other words, we were not given the task nor budget to restore everything. It was just bringing, every one of those teams actually, they were supposed to bring an idea and do one pilot structure and then train local people, if it's accepted by UNESCO, train local people to take it from there and do it gradually. As I said, this is a huge site, so it was not short undertaking, it was long term, still is going on. Okay, the idea came from here, at least as far as I'm concerned. This is Tajan Dam, Manjil Dam in Wood Bar. We had a 7.7 earthquake in June 21st, 1990. This is north of Tehran. 40,000 people got killed there. If those people remember that dam. And this dam was cracked all the way. This is a buttress dam. It cracked all the way from here to there. When I got there, actually back then, it was just 3 weeks after the earthquake. The reservoir was still full, and the water was gushing out of this area. What you see here, these are the sign of epoxy injection into the dam. These are the type of cracks they had there. This is the buttress, and you can see the width of the cracks due to the earthquake that we had back in 1990. And the idea was this, that drilled hole, first of all, injected epoxy into this concrete dam to penetrate through all those cracks, and then use strands or post-tensioning elements, steel elements. They were inserted here, injected by cement here, let it cure, let it harden. Then these strands were pulled. I don't know how many of you guys are civil engineers that, I hope I'm not, anyway, explain as much as possible. So it's just like a piece of rubber. When you pull it, and then if there's a structure, you let it go, you put a knot and let it go, it squeezes everything back together. So this is the idea. They put the steel, no, it's not happening. Okay, they drill the hole here, they drop the steel structure, these are all the steels that I'm talking about. And then they grouted it here, this is the crack. And they, on the other end, they pulled on this and then locked it. So what happens in effect, it pulls this cracked section back to the rest of the structure. So this is the method of retrofitting of a concrete structure damaged due to earthquake. This was what was done back in 1990 in Wood Bar. We took the same idea. However, problem with the steel. This is one of the structures in Arg, which during that restoration that I was talking about, they did before earthquake, they put the steel in there. Got the idea exactly from Italy. What happened? Every structure that had this in it was totally demolished. Nothing left of it. And that's quite normal. In the sense that if you get a sponge and put a nail through that, and then you push it by your hand, the sponge is not going to take any load. What's going to take the load is going to be that nail, and that nail is going to push through the other side of the structure and totally, actually, these became the cause of most of the devastation of the restored structures. Documentation shows that 100% of restored structure actually failed. We had a Yakhchal, which is a huge structure. I don't have a picture here. I have a picture in my system, though. which was like about 300 yards outside this. No restoration stood, no problem whatsoever. But whatever structure that they restored, it was totally damaged and demolished. And again, one of the reasons I realized that most of the people that they deal with this type of structure, they are architects. Very, very little, or people who work on historical, thing, mostly history rather than the structures. Very little knowledge regarding material properties. I had this experience right after that. UNESCO invited me. I went to northern Afghanistan to Mazar Sharif. Mazar Sharif, there is a mosque, oldest mosque in the world, which is called Gombat, 9 Dome Mosque. It's in Mazar Sharif. It's 1,200 years old. 800 years ago, got to an earthquake, and the roof fell. And some of the columns, huge columns, talking about 6 feet diameter columns, they all relocated. And they invited me, the group that they were with me went up there. They were all architects, and they were all people who did that. And they were exactly talking about the same system. It's funny, 800 years ago, that mosque was damaged, and it's just like a time capsule. The entire Afghanistan is like that. It's amazing. Afghanistan is just like Iran 2,000 years ago, nothing touched. I was spending time in the, I don't know what they call it, they French embassy had their own dwelling for the people who they invited by UNESCO. So I was there. They had a huge library of the documents, of historical documents there. And I went to a book that had a picture of that mosque, like about 150 years ago. And there were families standing in front of that mosque. So there was a book about that particular mosque. And if you took that picture and took a family of Afghanis, put them in front of them, take a picture, it would be exactly identical. Nothing has changed. So all the structure, historical structures, are intact. Whether ruined or, unless, I don't know, otherwise, as far as war is concerned with these crazy people who throw things away, that's a different story. But it's amazing. The whole, I think if one day Afghanistan becomes accessible by all people, it's much nicer than Rome that all of us have, probably most of us have seen, or you walk into a museum type of thing. Afghanistan is exactly the same thing. Nothing has changed, everything is intact. So it becomes safe. You go over there, you're directly in front of 2,000, 3,000 years of history. It's amazing, anyhow. Okay, what we did, we collected adobes, which are uncooked clay put in the form sun-dried. We took about 2,000 samples of those and have a guy, this guy, making a lot of new ones. Okay, but prior to do that, I have to know what kind of clay they used. Clay, for those of you who are not familiar with the material property of cylinder material property, clay with a little bit of sand, you mix it, its physical property changes. In order for us to find out, we do the gradation, we pulverized a lot of those adobes. We found what kind of dimension or grain size distribution of it, how much sand it was in it, and these are all, and with different amount of water, what would be their property. These are liquid limit plastic index for all the adobes, new adobes. And then we went to several places. We found identical type of clay, and we brought it to this guy. This guy, which is right there, that's the clay, to build it as it was built before. So thousands and thousands of these samples. This guy, that was his, and he had several guys trained right there to help him. They were making this stuff. Then we took these samples to Tehran and did some testing on that. We did unconfined compression testing, and we did shear testing. These are very standard tests we do in civil engineering routinely. And then we plotted the results of all the adobe and the new adobes to make sure they are similar, more or less. Same thing, uniaxial testing. This is very important. As I said, the strain property or deformation property is shown by what we call it modulus of elasticity of the material. In the sense, when you put a pressure on something, how much it deforms. You put 1 pound of pressure on a sponge, it deforms this much. If you put the same cross section but you put make out of wood, it's going to move that much. That movement is very important because when you are using a composite material, in other words, steel in that adobe structure, when it moves one way, the other one moves another way. That's why. And I will go through that later on. In reinforced concrete, if you guys have seen the concrete buildings, they put those rebars, steel rebars in there. The steel rebars, modulus of elasticity of steel is 10 times concrete. And they more or less deform the same. Thermal properties are the same. So basically, that's why they can use a composite material, concrete, reinforced concrete, that make buildings out of it. You cannot use aluminum. It has to be steel. You cannot use any other material. So because these two have some similarities that you can use together, because the deformation properties are close to each other, close enough that you can model it and you can build it. So it was very important for us to find out what material we're dealing with. What is the modulus of elasticity of this material? So these are the uniaxial tests on old adobe to find the modulus of elasticity. These are the new adobes. And we did a statistical analysis, and we came out that the new adobe of 96 MPa and old adobe of 82 MPa, which is very, very close, basically. So basically now we concluded that the new adobes behave exactly the same as the old adobe. As I mentioned about the material that they basically have a compatible modulus of elasticity. For concrete, as you see, 24,000 MPa. For steel, 205,000 MPa. So this is almost 10 times. So for adobe 85 to 95, we were looking for something, so we came up with propylene as reinforcing elements that we could use. Again, we are trying to mimic what we do in normal structural concrete design with the adobe structures. Then,
excuse me, just a question. So basically, at the beginning, you showed the UNESCO code for restoration of the. So, in what year was the Arg-e-Bam registered as a heritage like building?
About 10, 15 years prior.
Oh, okay. So at the time, they were allowed to use this steel, like because
yeah, that's true. That was not,
compatible with the code?
restoration was done by the Queen Farah during late 60s, early 60s to late 60s.
It didn't have to adapt to the UNESCO code at the time.
It was not even registered.
I see.
All the sites, by the way, all the sites registered by UNESCO, it was all happened after the revolution. Maybe back then UNESCO was not looking for that. They didn't have this mechanism. I have no idea. But I know I looked into it. Every site in Iran that's been registered by UNESCO as a World Heritage happened within the past 35 years. And the person who championed that, Professor Ad, he passed away last year. Very dear person. I mean, I worked very closely with him. He took me to Afghanistan. Amazing guy, amazing person. You know, very knowledgeable, deep knowledge of Iranian history. And actually, he was born in Afghanistan, but he was Iranian. His parents and they immigrated to Iran years and years ago. So they were a very famous family at the time. So, anyhow, injecting the cracks, as I mentioned, on the dam, we showed the epoxy we injected into cracks. Now we had to find something to inject into the cracks of adobe structure. So we are developing a new material, basically, is compatible with cracked adobe structure. And then we needed the bars for the reinforcement, external reinforcement. I will show you each one of these. And then finally plastering the elements with the straw reinforced mud, which is called kagel in Farsi, which has been used years and years in all the roofs in Tehran, and I remember that. I don't know. I don't think they use it anymore. But. Okay, for the grout, possibility of cement, lime, gypsum, all of that. But again, we need to make sure what works in that kind of structure. For example, you use cement, it doesn't adhere to adobe structure whatsoever. So we listed what are the possibilities, and then we came up with what to use. This is the grout, what the guy is drilling, and then injecting into some of the structures, the wounds over there, and then see how much it penetrates into crack or it's not penetrating into the cracks. These are all the tests we did there. I'll elaborate on those as well. And then proposed we use the material after exhaustive work. A lot of different types of grouts we made. We came up to the conclusion that lime, gypsum, sand, and this is a type of pozzolan, natural pozzolan, is basically volcanic ash that we, from natural sources, from mountains or volcanic ash, that we mixed with each other, had these properties that are very desirable. Minimum shrinkage in the sense that when you pour it in there, it doesn't shrink to have a gap. And flow is the viscosity, measure of viscosity, how viscous this material needs to be able to inject it inside the cracks. And then strength similar to adobe and durability, the rest of it. Okay, this is the marsh funnel, we call it, to measure the viscosity of fluid or the grout that we're making. And this is the homemade stuff to mix it together. And then what we did, we took some of the adobes, broke it down, put it in a cylinder, and inject the material from bottom up, and then took it apart and see how penetrating this material was. And this is the testing of the grout itself. And we put two adobes together with plaster with a gap in the middle and poured this material, this grout, in the middle, and we did the shear test to see how well they adhere to each other. Okay, normal injection material, injecting equipment that used in civil engineering, like for dams, goes hundreds and thousands of PSI to do that. For this material, which is very friable, very brittle material, we could not do any pressure, so everything was handmade. Basically, this guy, who's now, he's got his PhD now in Australia, he lives there, he made this stuff, hand pump, to inject this grout into adobe. This is also his production. It's one of the needle injection device that was at the other end of the hose to inject this grout into the cracks. Material considered for reinforcing element. Again, our choices could be, you have to eliminate one by one. So metal obviously was not one, and all this stuff.
This mortar was used for the new construction or what has remained from the old one?
Both. Basically, when we have cracks, we injected the cracks. For example, if the wall is standing and there are multiple cracks in there, we drill the hole and inject this material to fill up those cracks. And as well as when we want to reinforce something, drill a hole, drop a rebar, not a bar, it's called plastic or super pipe or PVC, polypropylene pipe in there, and put this grout right around it to adhere to the thing. Basically what we were trying to do, we were trying to add to the lateral capacity of the structures. Earthquake damages because the structure do not have lateral resistance. They fall and the roof falls down. So we wanted to use this reinforcing element to add to the lateral load-bearing capacity of the structure. But in order to keep the whole thing together, we use this grout basically as adhering or adhesion to keep the whole thing together. And proposed reinforcing material at the end of the line, as I said, was polypropylene that we used. Because, again, of similar modulus of elasticity. Okay, this is what I'm talking about. All right, these are the reinforcing. So if you, for example, if there's a wall here with cracks, we injected the grout into these cracks, we passed one of these elements through, and we bolted up both ends. Now, if you want to reverse it, you just take both away and pull it up.
Is it, again, one question going back to come up with that composite? Was it a trial and error?
No, I should. We set up a lab right there. And we made a lot of walls. And we loaded it, we cracked it. I show you a bunch of those. Anyhow, so the reinforcing elements that we use, these are the super pipe or polypropylene pipes. It's used for water consumption in households everywhere in Iran now, in modern housing. But these are polypropylene. And also this geogrids made out of polypropylene that we use that also for. Those are who maybe familiar with masonry structure for earthquake. Basically, every several layers you put a reinforcing mesh on the top, and then you build it up. We use exactly the same phenomenon. We use exactly the same phenomena for Adobe type of structure. Anyhow, okay, so this is basically one of the walls. As you can see, these are the cracks, right? Okay, these are the cracks that needs to be injected with that material or grout. Then reinforced with those polypropylene type of thing. This was the whole idea that we try to do everywhere, and externally also reinforcing the geotextile. Okay, then we decided we have to do a mock-up. We cannot go right away to the structure and do everything. So what we did, we set up a lab. This is our lab, right in the middle of it. We found a flat area. We made our own lab, and the idea is this: we are building walls with this dimension, 80 centimeter by 60, 110, 120 centimeter, and then we load it, let it crack, lateral loading, let it crack, inject it, put reinforcement, and load it again. So the initial testing, we get how much deformation we get. Retrofit it with our so-called method, do the testing again and see whether we are gaining or we are getting back all our strength that we had before. Okay, this is our lab, close picture of the lab. These are the reaction blocks made with the brick because you have to push against something. So we made, these are brick and concrete actually. And then walls are there, all around it. So we put a pushing element. This is the guy who's building these walls. These are actually adobe walls. Around every one of these reaction blocks. Then we loaded the wall, those adobe walls against this basically reaction block. It cracks when you load it. Then the guy comes and put this rebar elements in there, cover the face and inject it with the basically grout and put reinforcement to it. Then this is after all the injection has been done, all the external material pulled away, put geotextile that I was talking about, polypropylene geotextile, and then plastered it with kagel or mud, hay reinforced mud, which was all over the place. So this was done. Then we loaded. As you can see, in order to, because wall is not a wall alone, you have a roof or something on it. So we calculated how much roof between walls are situated certain distances apart from each other. So there's a vertical load on that. In order to have that vertical load, we used these sand bags and loaded these walls vertically. And then with a jack and all sorts of gauges up here, back here, and we pushed it originally and after repair. So we got some idea, and with this way we got like 95% of our strength back. In other words, the damaged, repaired structure was up to 95% of the original wall that we built.
So you assume the curved dome or a flat roof?
No, it doesn't matter whether, okay, see basically, when they have a curve or arch on the top, something needs to take your horizontal load. It's taken either by the next span or a very fat wall at outside of it, okay? Yeah, the horizontal component of that dome. Here we are just putting a vertical load on that, okay? Because everything eventually translates into vertical. It cannot go horizontal, it has to go into ground. And this is, how do I do this? I want to get this. This is one of the walls after it's been cracked. Let me see if I can do it this way.
یهو خودتون نریم سرت تو تخته نخورا.
This is after being tested.
برو ماشاءالله یعنی برعکس نه برو همینجوری برو فیلمش تموم شد Oh my God.
حتی کافی بشم برای
یه 4 ثانیه گرفتم برو
برید تو در تو اتوماتیک
نیافتی دوتا خدا فکر نمی‌کردم
Anyhow, back to okay. Now we go to an actual structure that we want to rebuild a pilot corner. It's called stable. The whole this was for horses, I guess, and it had rooms all around it. And this area was for livestock, like horses and stuff like that. But there are some holes on the wall that was for feeding the animals. And we were given these 2 rooms to rebuild as a pilot. Okay, I'm showing some of the condition of those 2 particular rooms, damage due to earthquake. Then this is our workshop, for example. We set up our workplace, scaffolding. These were all donated by the government of Japan. So we set up, this is our work area. All right, as you can see, reinforcing, they're inserting the reinforcement, the geogrids and the domes. Reinforcing and injecting, also putting to foundation.
Just a quick question. So in the beginning, you were talking about these steel rods and how it kind of, like the mismatch in deformability, something like that. So how do these plastic pipes differ from those?
Because it has the same modulus of elasticity.
Oh, okay.
Okay. Basically, the entire exhaustive work that we did, we were trying to find 2 compatible materials that can work with each other. Okay, and this is, as you can see, taking shape with the plastered. It's geogrid and then plastered. This is the final product, as you can see. We had to leave these windows open to the geogrid. Wherever we added something, we had to have few windows for whoever comes in the future see what's going on underneath. Okay, so it's Adobe. However, all this had to stay open. You could not cover that. I mean, this stuff here, and this is another picture. So basically, that's it.
One question.
Yes, sir.
If you wanted to restore the whole thing,
Right.
how long would it take?
Years. However, see, labor is cheap, as you all know, especially on those areas. So if we were given the chance, unfortunately, by the time we were done with this, Ahmadinejad became the president, and everything went flat. The entire organization of the Department of Tourism was changed as soon as he came to power. So the guy who was, Dr. Muhtari, who was manager of the entire site, he resigned, he went away. So basically, it went flat. I read in the news that they started rebuilding again 2 years ago, and they are saying by 2017 it's going to be completed. However, I don't know how. Whether they are following our model, they are following the Germans' model, or French model, I have no idea what they are doing. I just read it in the news. But we had a lot of laborers trained there. They were all working with us, like about 20 people all along. So if we were given a chance to train people by this method or any other method, there were plenty of people looking for work that they could do this kind of labor. It's not very brain surgery. It's a very easy thing to do, but at the same time, some thinking needs to go towards it, which unfortunately in the previous effort did not go through. Yes, sir.
Who was funding this?
Okay, me and the 3 students, we were not paid. We were not supposed to get paid for that. I mean, basically, it was a sort of, they paid for the materials. The Department of
who paid for
the Tourism Organization.
So is it internal funding or external?
No, it was internal.
You talked about Japan.
Japanese, they donated a lot of equipment, like scaffolding, a lot of small footprint dozers, and loaders and stuff like that, ambulances during the earthquake itself. But as far as the monetary help, I don't, if it was, I have no idea.
So it's under the Miras of
Yes, still is. Yeah, I'm sure you came over there. Yes.
So I think in terms of material research and the answers to the question, these methods could be applied to the local housing buildings as well, because some of the problem was probably because they are mixing indigenous materials with newer types of construction. So I was imagining that this research would be very beneficial to the actual repair of the city as well.
You're absolutely right. Basically, my experience after Root Bar earthquake, which happened back in 1990, when it was rebuilt, God forbid if you get another earthquake there, it's going to be worse. It's going to be worse this time. Because very little engineering judgment goes into the thing, and on this particular case, I remember Khatami government, or his organization in charge of whatever it was, Ministry of Tourism, they decided to hire a big consulting firm to design based on the old map of the town and build it by the government and give the dome to people. Then started screaming back and forth, oh, they're going to steal money and this and that and Basel and this kind of stuff. Then order came from way above that give money to people for themselves to build it. So what happened was they gave $5 million to each family to start. They were supposed to be in 4 installments. They said if you put the foundation down, come back for the second installment, another $5 million and up to $20 million. People got that $5 million. They were living in connexes, in metal connexes that were donated by different organizations. They went all by the car, by a pride, and nobody built it. Still people, most of the people living in the same situation as they were during the first year of the earthquake, unfortunately. But you're absolutely correct. I mean, this stuff never been published. It's just the first time I'm presenting it here.
You would love to get it published in the Iranian Studies Group sometime soon.
You can do that. It's not a big deal. But what I'm saying is, it's just amazing that it's not organized in that sense that we use. See, people normally build their houses with the readily material around them. This has been the case thousands of years. They ask you why in the US, wood structure, why all the houses are mostly wood. Because wood is cheaper here, okay? So I'm sure if wood was more expensive than steel, people use steel, right? So wood is readily available. It's a green country, a lot of wood. Wood is available and people build it with wood. In Iran, in those, Afghanistan, Tajikistan, most of those countries, or North African countries, the only thing they have at their disposal is mud. It's clay. So they build it with that. Now, if there's some thinking goes into it, to build some lateral capacity into the structure, definitely would be safe. But has not gone that way yet. I hope one day will.
I have two quick questions. Actually, I forgot in my introduction to tell you also taught for some years in Tehran University, so I really enjoyed your presentation and thank Professor. My questions was actually in a follow-up to your question. As you said, so Iranians for a few thousand years they used to build these structures, and as you said, it's a land that has seen, I guess, many earthquakes. What was there any mechanism, like in kind of historically or ancient Iranian architecture, or basically as a resistance to those sort of like basic destruction?
Frankly, earthquake engineering is very new. Total world of science. Earthquake engineering is very new. Prior to this, probably has 150 years. I don't know, I'm not going to put a number on that, I don't know. But I know it's fairly new. Prior to that, it was act of God. So that's it, we couldn't do it.
So that wasn't something, for example, Iranian architects historically used to think about as they were building the structure?
There is no evidence. If there is no evidence. But in northern Iran, that people, right after Rudbar earthquake, I went to Iran and I did a tour of north of Iran. The old traditional houses built by the villagers were all wood structure, they all stood. With all the modern structure fell. So what I'm trying to say is that even earthquake engineering, even though it's modern, but at least goes 100 years back. These buildings I'm talking about in Rudbar or in Rasht, it was built 15 years ago. And it fell a lot of it, unfortunately. Yes, sir.
I just want to mention, perhaps as maybe a final point, I believe that construction is a teamwork. And you mentioned that the restoration that happened at the time of Queen Farah was architects took over and everything fell because of lack of knowledge about materials. And it's unfortunate to see how lack of collaboration and coordination between engineers and architects can cause such disasters. And I'm curious to know, you mentioned that your team was you and a few students that you had. Compared to your team and the other teams that are working from UNESCO on this project, how do you find the collaboration between architects and engineers? Because I believe the attention of details can come from the architect's side, and then they need to work closely with engineers to make the structure as stable and as beautiful that it was before.
Basically, when I started my graduate study of Virginia Tech, very old, I don't want to say how old I am, but basically cross science or working between different disciplines just was starting in late 80s. Okay. Prior to that, everybody was his own island. The whole thing, one of the reasons they say the amount of knowledge human being gained within past, let's say, from early 80s till now, somebody was saying is twice as much as the whole humanity from beginning till, One of the reasons is the collaboration between different
parties.
Yeah, different branches of science. And see, historically, there would not been a good relationship between engineers and architects.
It still doesn't, unfortunately.
There's a joke about it. But I remember one time I was designing a underground station for North Shore subway tunnel in Pittsburgh. And this architect designed a huge wall. And I'm asking the guy, hey, this is not going to stand up. Physics doesn't work. You need to come up with something to, you know. So no, but this is, I want everybody to see everything. I said, I know, but this is not going to work the way you have it. But in general, we had a lot of this discussion. I'm just saying it as a joke. But at the same time, yeah, unfortunately, the teams that I dealt with, at least when I went to Afghanistan with the French, there were 3 French and 2 Italian. They were all architects. And when I was telling them that this building that we are talking about, you cannot reinforce it with steel, they said no. And then I went to all these mathematical thing, you know, modular elasticity does that, and this and that. Oh, okay. But fortunately or unfortunately, a week later, there was so much bombing there that everybody escaped. I didn't hear about that project anymore. We were supposed to put a proposal to rebuild that, to restore it, basically. But unfortunately, it didn't happen. But what I'm trying to say, now it's a lot more collaboration. Nowadays, with the state of communication and stuff like that,
you mean
we are learning a lot more from the other party and vice versa.
You mean in Iran, you sense that nowadays there are more...
Definitely,
okay.
Definitely. I mean, here, the thing that I was saying, it was not particular about Iran, it was everywhere, basically. I was at Virginia Tech, again, we didn't know, across from the hall, and the guy went to, like, mechanical engineering. We had nothing to do with each other. But, you know, the collaboration has changed everything a lot.
I think that, I guess that's the last question, but you guys are welcome around. Welcome to stay around to chat more with Professor Dr. Kashi.
Well, I'm not professor.
I don't know why you did teach in Tehran University and also in the US, yeah, so basically we take that history as the, that's what I remember. And you're welcome to stay around, there's some food and snacks left. And please join me again thanking Dr. Kashi and all of you.
Thank you.